Yeah. All right, so I'm going to try to record this so that way I can post it up there and you guys can use it for studying when you study for the exam next week on Thursday. So remember that there's an exam next Thursday. Okay? We'll talk about it more on next Monday. So what we're going to work on real quick is a closing the horizon problem. So closing the horizon would be an L. Oh, that's so fuzzy. Or maybe it's just the paper. There, that's good. All right, so I'm going to just draw the scenario here for you. So say we have an angle that we're recording, okay? And these points, 1, 2, 3, are the points that we're measuring the angle between, okay? So we're going to be measuring this angle and this angle in closing the horizon. So if you remember the closing the horizon problem, basically you're closing that angle. So when we did this in with the vertical, measuring the vertical angle, we closed the horizon. Well, now we're talking about closing it horizontal, okay? So the way that we're going to basically display this, we'll talk about the interior angle first. Okay. And that interior angle, I'm going to give you a bunch of measurements. So that interior angle would be displayed 1, 2, 3. That would make that angle. So it's angle 1, 2, 3. Okay. And my first thing I do is my back sight. So my back sight is set to 0 degrees, 0 minutes, 0 seconds. Okay, so I 0 set on that. And then I have the angles that I record. Okay, so I have angle 1 be 91 degrees, even though it doesn't look like that up here. All right, 0, 0, 25. My second set of angles that I turn, 91, 0, 0, 35, 91, 0, 0, 15, and 91, 0, 0, 39. Okay, so these are all turned for that interior angle, this angle here. Okay, so this angle here is that interior angle we're looking at. These are all the angles. So what we're going to want to do is figure out the mean angle. All right, and then an adjusted angle. We can't do that yet. I mean, we can figure out the mean right now if we want to, but let me complete the whole problem here. Let's say that this is 300 feet. Okay. Between those, that'll come into play here in a little bit. So let's write down our exterior angles that were measured. Okay, so now the angle that I'm looking at for my exterior angle is going to be this angle right here. Okay, so that angle now is displayed 3, 2, 1 because it's the exterior part of the angle turning from right. Okay, so that exterior angle is going to be displayed as 3, 2, 1. All right, so we do our back sight and we 0 set it. And then we record our angles down. We took 4 different measurements on it. Okay, so those are our 4 different measurements. And then we have the mean angle, the adjusted angle, okay? And then there's a few other things we're going to look at here. The other things that we want to be able to figure out to solve all this is we want to figure out that total of the angles. So does that total up to 360 is what we're looking for, okay? It should, I mean, technically it should. Mathematically it should, but it's probably not going to because there's instrument error. So we're going to have to adjust those angles, okay? So total of the angles, and then the angular error. The distance error. And precision. So those are things we're going to find. Okay. All right. So let's start up at the top here, even though I wish I could fit that all in there. I guess I can. Hang on for a second. I want to make it all fuzzy. There. Not quite there yet. Maybe that's why Tim has his all set up like this. All right, we can see all that pretty much. All right, so let's talk about this interior angle we turned first. We want to figure out the mean of that angle is. So what is the average, I guess, of all those angles? That's basically what we're looking for with the mean. Okay. So we're going to basically add them all together and divide by 4, and that'll give us what that actual angle is, averaged, okay? So if someone can tell me what the average angle is there, I know it, I've already figured it out, but I want you guys to tell me what that average angle is. Go for it. Tell me it.
91 degrees, 0 minutes, and 28.5 seconds.
91 degrees, 0.8 minutes.
Yep, and then 28.5 seconds.
28.5 seconds. I would agree with that. Okay. All right. So let's figure out what the mean of the exterior angles is. What is the mean of the exterior angles? Now this one, when we get going on this, it's going to be a tad bit confusing because of the way that we're going to adjust. Okay, so for this interior angle is as if we turned the angle 4 times here. Now we're working with this exterior angle down here. It's going to be like we turned this thing 4 times. And got that, so that way we could average it. You'll notice in surveying there's a lot done with averaging. Anybody have the answer?
269 degrees.
So 269 degrees,
0 minutes.
0 minutes,
18.5 seconds.
18.5 seconds. Okay? So that's we figured out both of our mean angles. The next thing we want to do is total up those mean angles, right? So I want to add our mean angle of 91 degrees, 0 minutes, 28.5 seconds. I want to add it to 269 degrees, 0 minutes, 18.5 seconds. What does that give me if I add those two together? So that's where we're going to fill in this total of the angles.
I had 360 degrees,
360 degrees,
0 minutes,
0 minutes,
and 47 seconds.
47 seconds. Okay, so that's all fine and dandy, but we have that what should happen here is this should technically total 360 degrees, right? So what is our angular error? What would you say our angular error is? So if I take 360 degrees, 0 minutes, 47 seconds, and then subtract 360 from it, what do I get?
0 degrees.
So I get 47 seconds, okay? So that's our angular error. 0 degrees, 0 minutes, 47 seconds, okay? All right, so we're going to worry about the distance error here in a little bit, but now we're going to go through and adjust our angles. So if I'm trying to achieve 360 degrees here, and I'm trying to adjust the 360 degrees, or adjust to 360 degrees, we know that our error is 47 seconds. We want to take that off equally from each angle, because we're working with one angle, okay? So what I want to do there is, because I have two readings, essentially, two averaged readings, I'm going to adjust the angle evenly amongst those two averages, okay? So I'm going to take 47 seconds and divide that by 2, okay? So what is that if I divide it by 2? Anybody off the top of their head? 23 and a half. Okay, so 23 and a half seconds. So I'm going to take away or add 23 and a half seconds to each one of those. Do I add it or take it away?
Take it away.
Taking it away, right? Because it's above 360. If it was below 360, then I'd be adding it. So I'm going to be taking that away. Okay? So now that I'm taking that away, what does that make my adjusted angle for the first one here? If I take away 23 and a half seconds, what does it make my angle? 91 degrees, 0 minutes, 0.5 seconds. Okay? All right, how about the adjusted angle down here then? 268 degrees, 0 minutes, 55 seconds. Good job. Off the top of your head too. Nice. All right, good. All right, so now we can figure out the rest of our stuff here, the distance error and the precision. Okay, so there's the distance error we figure out by a nifty little, we use the sine function, okay? So this distance error that we're trying to figure out is the sine of the angular error, okay? So the error times the distance, averaged distance, okay? So I have 300 here, 300 here. So I add these two together, divide by 2. So I have two lines, okay? So if I did that average, I would have the sine of 47 minutes times 300. That's my average distance, okay? Adding the two 300s together, divide by 2. So if this distance was like, I don't know, say 400, and this distance was 200, if I add them together, divide by 2, I'm going to get 300 for my average, okay? So just remember that this is an averaged distance, okay? So if I take the sine of 47 seconds, now remember you got to put the degrees minutes in front of that before you do 47 seconds, so that way you get the right decimal place when you spit it out. What is my distance error? You can spit it out when you get it.
219.406.
A little too high. You gotta remember to use 47 seconds. You got it?
0.068.
0.068, 8. Make sure you use the leading 0 when you're doing your calculations and stuff, because I will mark off for that. Okay, that is a significant digit. We have to show it. Make sure you have the 0 there. Okay, 0.068. All right, so how do we figure out the precision then? Okay, so precision is figured out by total distance. In this case, it's average distance. Okay, so this 300 again we have here, that's the average distance, divided by that distance error. Okay, so we have 300 divided by 0.068. Okay, so average distance divided by distance error. And that's going to give us this larger number that will be displayed as 1 to some number. Okay? So what is the answer there? We'll round to the whole digit, the whole ones place, I guess. What does this equal?
4,389.
Okay.
No, I got 4,412.
4,412. That's what I would guess. So, okay. So how this precision is displayed is it's 1 in 4,412. So this could be you're off 1 inch in 4,412 inches, 1 foot in 4,412 feet, 1 mile in 4,412 miles. It's unitless and it can be used or displayed any way. Okay, so we don't ever put a unit on here. It's not feet, it's not anything, it's a ratio. Okay, so that's how precision is displayed in surveying. Now, in surveying, it depends on the application. This 300 in this application is an average distance. When we go and we do a traverse and we look at precision with a traverse, we're using total traveled distance. Okay, so this is not always the case in surveying. You're not always using the average. Okay, so this is the only real case that you're going to be using average is when you're dealing with just an angle. But when you tie a bunch of angles together in a traverse, then you're using total distance traveled. Okay, so that's important to know as we go through this. Okay, so this is the closing the horizon problem. You guys are going to end up doing this after you collect the angles you do today when we're out in the field. Okay, and we're going to talk about those notes and what they look like here right now. One thing I wanted to say is I posted a homework set for this particular problem that we just did that's due Saturday. The reason it's due Saturday is I want to get it graded for Monday in case there's questions. Okay, so make sure you get it done. It's not this, I mean, it's not exactly this problem, but it's very, very similar. If you follow what we just did, you'll be able to complete that homework no problem. Okay? So that's closing the horizon. Let's talk about what the field notes look like for today's activity. Yeah, field notes. I wish I was going to grab a better pen, but we're going to have to swag it with the blue pen. Okay? So today we're going to go and complete the exercise, the very last exercise. Oh, why isn't it not grabbing that? Oh, there it is. Okay, so we have these lab exercises. We're going to do this balance or angle balance. So we're going to start today. You guys will have the option to finish it on Monday, but hopefully we can all finish it today because Monday we're going to spend time reviewing for the exam on Thursday. Okay. So the angle balance. What we're going to do is we're going to go out into the field. We're going to set up total station and we're going to measure 4 sets of angles. So we always want to make sure when we're measuring angles and we want to have a closed figure that we measure an angle on every single point that we're set up on. Okay. So we're going to have 4 points. It means we should have 4 sets of angles that are measured. 1 on each point. Okay? In here I say I want you to set up about 300 feet. Now about 300 feet, it depends on where you're setting up. We're going to go out right out here in the parking lot probably and do this. So if you can't get 300 feet, fine. But I'm just using that as a guide. So it's not dead on 300 feet. If all you can get is 450 feet, whatever, okay? I just don't want everybody out there doing a 10 foot by 10 foot square, because that doesn't help at all, okay? So what we're going to do is we're going to go and do this close the horizon problem and record the results in our field book. So I'm going to show you how we're going to set up the field book and how those measurements are recorded, what your sketches are going to look like, things like that, okay? So like I said before, I'm recording this so that way you guys have this for later on. You can see how we set all this up. All right, field notes. Let me zoom in a bit. All right, so let's talk about the cover page first. All right, so this is like I just opened the book. Matter of fact, I thought I brought a field book in here with me. Must have left it on my desk, okay. Or did I leave it there? No? Okay. All right, so I'll do it on here. So pretend like I just opened up my field book, okay? Right side of the page, left side of the page. Title of page goes on the right-hand side. All right, so this activity is going to be called angle balance. Using closing the horizon. Okay, so that's the name of this activity. It is on the NWTC campus. The weather today say 70 degrees and sunny. The equipment needed or used. Total station. Three tripods.
Also, it's very windy outside.
And windy, / windy. Okay. 3 tripods. 2 prism assemblies. Okay. 4 nails. Now you're going to want ribbon for those nails so you can find them again, because I don't want to just leave the nails out in the lawn out there. After we're done with this activity, we're going to pull them. Okay? Pull those nails out, or else we'll end up with iron all over the place out there. All right, so we have a total station, tripods, prism assemblies, and nails. Anything else? I'll put ribbon on there. You obviously are going to have your field books, so you don't have to write that down. All right, so the crew is your initials. Okay, we'll say it's me and Tim on a crew. I wish Tim's middle name was N, T&T. Pretty cool. Okay, crew. What else do I have to display on here? Is there anything else that I should put on here?
Date.
The date. Very good. Date. Okay, what's today's date? 9/26/19. Okay? That's first page. Anything else? What's that?
Time?
Yeah, you can put the time on there if you want. I'm not too particularly worried about the time. for this go around. You probably display a range of time, you know, make it the class range, maybe 12 to 320 or whatever. Okay. All right, so that's the cover page. Okay, so you have all that sort of filled in. I just gave you what you're going to need out there. Remember, the total station needs batteries, so make sure you grab batteries. We're not going to put that in the notes. You should know that by now. Okay, for displaying angles. We're not shooting distance at all this time. Okay. All right, so we did the cover page. Now we flip the page, and we're on a new spread. And we're going to take and fill in all of our data over here, and our mapping is now going to be over here, or our sketches, okay, and notes. So what we're going to end up doing is we're going to collect the angles for a four-sided figure. So in my notes, I'm going to put in angle. Okay. And let me jump over to the side here first. Okay, so we're going to be out, you're going to pick your location. Before you write your field notes, sort of figure out what your closed square is going to be, or what your square area is going to be. Draw your sketch. Okay, so say I'm out in the field and my square area looks something like this. Okay? And I want to make sure I have my north arrow on there. And my scale. So if you guys can try to draw this to scale, it might be great. All right? So I'm going to say on here is 1 inch equals 100 feet. That's my scale. Okay? 1 inch equals 100 feet. All right, so each one of these points that I'm circling in right now are nails that I put out in the field. Okay? Now I'm going to start here at number 1, 2, 3, 4. All right? I have a road going through the middle of my site. Okay? That looks sort of like this, and I'll say this is Taylor Street and Campus Drive. Okay? This is just really, you guys don't have to be drawing this right now. You don't. Because you're going to be set up on
that street that's up to the west.
Yeah, I don't really care what street it is. I'm just making it up right now. Okay. So, this is what your sketch should look like. Okay? On the side. This is going to identify what points that you're set up on when you're over here doing these notes. So my first angle I'm going to set up on is most likely going to be, I'm sitting up my total station on 1, and I'm back sighting number 4, because we're turning angles to the right. Okay? So sitting on 1, back sighting 4, and foresighting to number 2. Okay? So I'm going to go, the angle is going to be derived as 4, 1, 2. 4 is the back sight, 1 is the occupied point, 2 is the foresight. Okay? 4, 1, 2. That's the angle that I'm going to do. So I'm going to take and write down interior here. So I remember which ones are interior angles and exterior angles, so that way I don't mess myself up. Okay? And then I'm going to go direct, reverse. Okay? So taking a direct shot here, reversing the scope, re-back sighting, taking a reverse shot. Okay? Then I'm going to take and figure out the mean angle here. And then I'm going to jump down and figure out the exterior angle. Direct, reverse, and figure out the mean of that. All right? We're going to have the total angle average. And then the adjusted average. both things will be filled out after you get done, okay, with all your measurements. So when you're measuring out there, you're going to measure these items right here, okay? So direct reverse, direct reverse. Don't worry about meaning them until you come in here. You can do that calculation when you get back in. So all we're doing is filling in a direct reverse for each one of these angles, okay? So that brings us to the next one then. The next angle that we're going to turn, we're going to move up, okay? So the next angle is going to be 1, 2, 3. Backsighting 1, occupying or sitting on with the total station number 2, foresighting number 3. So that brings us to 1-2-3. And we're going to do the interior. And that's direct, reverse, mean, exterior, direct, reverse, mean, and then we have the total angle average, and then the adjusted average. Okay? Oh, that's all right. You can skip to the next page. Okay? All right. So let me flip to another page here if I have another one. Okay, so we're jumping to a new page. Or if you're in your book, you don't have to, whatever. If you need to, you can. Okay, so now we're going to jump and do the same thing. We're going to refill in angle here. Right interior. And this time, if we look at our sketch, you don't have to make the sketch on the next page. We're actually going to be backsighting 2, occupying 3, foresighting 4. So our angle is going to be 2-3-4. Okay? Direct, reverse, mean, exterior, direct, reverse, mean, okay, then the total average, and the adjusted. All right, so figured that one out. Now I'm on my last angle. Remember I said we were going to have an angle for each point. So we've done 1, 2, and 3. Now we're going to turn an angle at 4. So this one is going to be backsighting 3, turning a right angle around 4, and foresighting 1. So it's going to be 3, 4, 1. 3, 4, 1. Okay, direct reverse, mean. Our exterior, direct, reverse, mean, total adjusted, our total average, sorry, and then adjusted average.
If we're not going to be sketching anything on this next page, can we just continue our notes over here?
Absolutely. So a good question. You have all this blank space here, right? Because you're not sketching your sketch there. So you could use this space for any kind of notes. Special notes about your angle. Your math can be done over here. Okay? It can also be done down here. Some of the math can be done down here, no problem. But this is a nice big open page you can do a lot of your math on. Okay? So that completes all the angle measurements that we're going to need to take out in the field. All right? So we're going to have 4 separate sets of angles for each one, okay, that you're going to average. Now, once you're done averaging these angles, the angle that you're going to use or you're going to display in here is that interior angle form, because that's the angle that you're going to use at the end of this, where we're going to actually do our angle average. So when it comes to the angle average, say my adjusted, now you guys don't have to write any of this down, say my adjusted angles when I display them in here come to be, say this one is 90 degrees 00 minutes 00 seconds, so it's perfect right angle. Say this one is 89 degrees 30 minutes 00 seconds. Say this one turns out to be 90 degrees 00 minutes. Okay, so we're got like a little rhombus going on. And this one comes out to be 91 or 90 degrees 31 minutes 00 seconds. Okay, say that's what the angles come out to be. Now there's another thing we have to do here. Okay, so after we average all our angles, these are my averaged angles after I get done. I can figure out what the closed figure needs to be by using n minus 2 times 180. Okay? So what's n? So n is the number of sides of the figure. Okay? So n minus 2 times 180 will give us what we should have for our total angle in that figure. Okay, so in this case I have 1, 2, 3, 4 sides. Okay, so I should have 4 minus 2 times 180. What does that equal for the angular, the perceived or needed angular, okay, angular total? It should be 360 degrees, right? Well, if I take and add these together, I'm going to end up 1 minute above that. So I'm going to be at, so if I took and added all these together, 90 degrees, 90 degrees, 89 degrees, 30 minutes, 00 seconds, and 90 degrees, 31 minutes, 00 seconds. If I add those together, I'm going to come up with 360 degrees, 01 minutes, 00 seconds. Okay, there's an issue there. I'm off by 1 minute. I have to adjust that evenly amongst those 4 angles then, that minute. Okay, so now you're adjusting again. Right, we adjusted here, we meaned our angle, added an adjustment just like we did in the closing the horizon problem that we just did. Okay. We adjusted those. Now we're adjusting again to make the figure close. Lots of adjustments. Okay? Normally you're not off by a whole minute. That's extreme. Normally this is maybe 10, 15 seconds that you're adjusting through. If you're off by a minute, I'd say go turn your angles again because it's not good. Okay? So if I take 360, 01, 00, figure that out, 0 degrees, 01 minutes, 00 seconds. Now I take that and divide that by 4. Okay, so I'm going to adjust my adjustment after I do this math divided by 4. It's going to be 15 seconds per angle. Okay, so I have to take and subtract 15 seconds off of each one of these. And that will give me my closed figure to be closed exactly 360 degrees. Okay? That's what I'm looking for us to do when we go out in the field. Okay, so all this math can happen over here if you want to. And if you have to flip to the next page because you have too much on there or you write big, that's fine also, okay? But if you do flip to the next page and it's empty, you can use both sides for your calculations. All your calculations don't have to end up over here, okay? That's what our exercise is going to be today. So when we go out in the field, grab all your equipment that we wrote down and pick your area, stick the nails you're going to set up over, and we're going to set up perfectly over each nail and turn as good at angles as you can. And if you're off, okay, if I'm reading 89, 50, 50 on the first angle, don't automatically set it so it's 89, 50, 50, because where you backsighted to is going to change also. It's okay to have different angles, all right? Don't fake it, because that doesn't do anything. Your integrity goes right out the window if you're trying to fake stuff in industry. So do the angles as they are. You're going to have to do math, and that's okay, all right? So that is how we're going to take and go out in the field and do this. So make sure you grab all the equipment. First shot, we're going to go to the parking lot out here. Everybody set up their first setup, so that way they're close to each other, so that way I can grab one of them and talk you through the process, okay? So that's what we're going to do. Go ahead and go out and set up.